AI may be the most powerful tool ever developed. It's still just a tool in our tool belt. It thinks we're just tools.
And that was Dr. Vivienne Ming, neuroscientist, entrepreneur, technologist, and author of Robot Proof. And the deeper question behind it, if we want better AI, do we first need to build better people? What does it actually mean to be robot-proof in a world where artificial intelligence can write, code, analyze, recommend, diagnose, tutor, and even imitate creativity? It's a powerful tool. Maybe the most powerful tool that humanity has ever built, next to vaccines. But how it changes us depends on how we use it, what we understand, whether we are willing to stay deeply engaged in the work, and what hybrid intelligence really looks like. So, I'm Autumn Phaneuf, and I'm joined by my co-host, Noah John Siracusa, on this episode of Breaking Math.
Why did you write this book, Robot Proof, now? What was really the main message you're hoping to get across with it?
Wow. Right off the bat, I've got a big messy answer for you because I didn't write this book now. Long ago, I think like maybe 2014 or something, I gave a talk at TED Med, TED's medical focus conference, and immediately started getting people writing me and saying you should write a book. Sometime around that same year, I visited the U.S. Department of Education. For some of our younger listeners, that's a thing that used to exist and used to actually spend money trying to improve education in the United States, maybe deeply imperfectly, but with good intentions. So I got invited there, and I gave a talk, and it was not wildly different than what I write about in this book, because it turns out what I'm writing about is people, not AI, and people just don't change that much. So I got off the stage, and they say, Dr. Ming, how can we robot-proof our kids? Which was the original title of this book. It remains the title of a chapter in the book. And I immediately thought someday that's going to be the title of a book. But when I responded to them with all the things I would do, they responded, yeah. But like, if it was just a 6-week job retraining program, what would you do? To which I could only respond, I would do nothing, because that wouldn't actually change any of this. So I started writing that book back over 10 years ago. What inspired me to finally publish this book was watching Sam Altman get up in front of the U.S. Congress and say, imagine a world in which every child has their own AI tutor. An amazing thing, one that many science fiction fans don't have to imagine because they read The Diamond Age or any number of other books, that's full of AI tutors. Another one of a very similar name that's not the greatest book, but it's so full of ideas, is called actually The Golden Age, and it's from a similar time period. So 2 sci-fi plugs, if you can find the latter, it might be out of print. But forget the science fiction. I don't have to imagine it, because AI in education has been studied for 50 years. And if there's a golden rule, it is that if an AI tutor ever gives students the answers, they never learn anything. And it's a rule that has been replicated with large language models and specialized agentic tools. Generally speaking, once AI gets involved, student learning gets worse. Not because it has to, not because AI is bad, but because the nature of the interaction between, let's call them the median student, and a tool that has all of the information available to it. Let's not worry about hallucinations or the limitations of existing large language models and just assume we're getting great answers, which honestly, for a lot of very modern models run at their highest levels, is a pretty reliable assumption for most student level information. It doesn't matter. There's a technical term in ed tech research literature, which is my favorite one, which comes also out of science fiction, which is sleazing. And is the term, a more common one is satisficing, doing just enough to meet the requirement. But sleazing is figuring out how to satisfy the requirement without learning anything. In other words, without actually engaging with the technology in the way it was meant to be used, like figuring out if I just hit the return key over and over again, eventually the AI tutor will give me the answer. And then I submit the answer and I get full credit. So students are great at figuring this sort of thing out.
Can I zero in on one thing here? You used the phrase here, the median student, but I remember in your book, you mentioned that there is no such thing as the average student. So what I'd like to ask is, on the one hand, I hear discussion that AI allows for these individualized tutors that really get to know us. On the other hand, there's a lot of discourse that it kind of is a regression to the mean. It kind of averages all humanity into one central lump. So is AI more individualistic or is it more aggregate? What do you think?
I was notably careful in saying the median, in that we could literally identify a single person who represents the median, whereas, to be very pointed about it, often in large population studies, averages represent people that don't even exist within the population. So this is the problem. Everyone wants easy answers, yet the very nature of your question, both of those things are true. AI is an immensely personalizable technology. That's its strength and one of its biggest flaws. People are highly heterogeneous themselves, and so they respond wildly differently. You might think of it as there's a paper title from, among other people, Nobel Prize-winning economist Daron Acemoglu, which is the race between technology and education. There's also might be something of a race between the interaction of, and I'm way oversimplifying, model-based cognition and learning in humans and model-free cognition and learning in humans, and how those two interact, even within an individual with AI. So you're looking for quick, shallow responses, or are you really pushing back and sort of growing a model of the world? Again, I'm really oversimplifying here, but not only across populations, but within individuals, these different systems are interacting in different ways. They produce different behaviors. I'm being really nerdy in a way that I would not, with CNBC on this topic, but the way these interact means even within an individual, their behavior and interacting with AI will be different in different contexts. So when you get this sweeping, imagine a world in which every child has their own AI tutor. Yes, I can imagine a world in which those tutors are highly individualized and providing just what the students need. And I can imagine a world in which it produces just what the students want in many contexts, which is a quick and easy answer that gets the work done, and they never learn anything. And in fact, in the real world, both of those are happening. They're happening within and across learners. And then the scary part is looking at a representation of the actual numbers, which is the vastly larger population are those that are getting quick, easy, shallow interactions and getting their work done. And really, we're seeing drops in cognitive engagement and learning. You can see it in Anthropic's own data with adult professional programmers, as well as my recent experiment. And we see students that really leverage it hard and take off. Those are both true things. And I don't know, it's like everyone just wants it. I often call it this sort of magic wand or magic genie, like that somehow AI itself will fix all of AI's problems or all of our problems. And, 30 years in to the complete dumb luck of being in this field, and it never does. Never. So this is the tension in this space, whether it's education or beyond, is humans are messy. Now we've made artificial intelligence, which itself is so complex that it's also become very messy. And the interaction between the two is just sort of exponentially more so.
Now that makes me think a lot more about how do we build better people, especially when you're integrating these systems with human intelligence and artificial intelligence. Can you tell us your thoughts about that relationship on how we're building that trajectory?
Yeah, the magic holder of all of the answers. Well, I have had an interesting career, which gifts me, I think, very different than many others, having not solely been, an empirical or theoretical scientist, not having solely been an entrepreneur or a computer scientist. Most of what I do is applied philanthropic work, though I occasionally still publish papers and I occasionally still stupidly build companies. So I get confronted with problems in health and just generalized human welfare in education and workforce. Since I'm usually paying for this, all I care about is that it works. And in that sense, AI is the most astonishing tool humanity has ever developed. Even before we get into agentic large language models or modern massive scale reinforcement learning systems, even back 10 years ago, when I was coding things up by hand and working with, you know, hierarchical latent Dirichlet models or home-brewed early deep neural networks, they were still already doing truly amazing things. But they were doing them in these sort of blind ways. You had to really put this stuff in context. So one thing I would note, maybe whether we're talking about applied scientists or engineers or students or just everyday workers making use of AI, is something from my experiment. And I think we'll probably have a chance to go back and talk about some of the specifics here. But there's a common line also used by Sam Altman and by OpenAI, and for that matter, by Google and Microsoft and many others, which is AI will do all the boring work so you can do the fun, creative stuff. So if you're a working scientist, maybe AI develops all your methodology. It does a lot of the paper writing. It helps you with your statistical analysis. So again, I have this experiment that we can go into in detail, but I'm going to jump to one specific finding. Those people that show exceptional, sort of not both superhuman and super AI performance when they're collaborating with AIs. So better than what natural intelligence would have produced by itself, better than what artificial intelligence would have produced by itself. I'm going to call this hybrid intelligence. When that hybrid intelligence rises above the other two, what do we see? Well, it is absolutely not the AI does the boring stuff, the human does the fun stuff. What we do see is, and forgive me, I'm a nerd, and it isn't even my term, but I'm certainly going to use it. Let's call them cyborgs. In our cyborgs that show this top performance, they are deeply engaged in low-level, let's say, data analysis or low-level writing tasks or methodology development. And so is the AI. And they are leveraging the AI in high-level exploratory tasks as well. In other words, it isn't that there are automated tasks and then there are human tasks. But this is why I'm using this term cyborg. There are these irreducible cognitive processes of the two working together. And when we look at what actually predicts that, it turns out it's very human. All of the factors that really pop are not things like AI benchmarks. They are fundamentally human factors. And so if we're looking at how do we change this in education, how do we change this in our daily lives, really, in some ways, work does not fundamentally change. The people that are, in many ways, the most elite in their fields, I guarantee you, are exploring They're getting messy with the data. They're thinking deeply about it. They are questioning themselves skeptically like any good scientist should do. We could run through this list, but, the sort of unfortunate truth for anyone that doesn't want to have to learn how to factorize a polynomial is you probably still need to know how to do that and learn, what are the complementary families for your various, Bayesian models, even though you yourself probably won't be doing the implementation of them. But if you don't know why do I need to factorize this polynomial right now? Here's a question I actually ask of many engineers that work for me, and I'm always shocked by their inability to answer it because it's so basic. What are the basic mathematical assumptions of principal component analysis? Something that's been around for decades and decades and decades. If you even want to call it machine learning, the most simple of machine learning. And I get answers like, oh, it's about dimensionality reduction. What? No, that's not what I asked you. What are the mathematical assumptions? If the world doesn't follow these, are you violating these assumptions? And very smart people with very fancy degrees can't answer that. And in many ways, I don't blame them. I blame their schools. I blame the system that got them to just memorize how to do a thing without knowing why to do a thing. So this is why it actually is really important. Yes, you still need to know how to do stuff because you need to know why. Because your new partner, or if you're really geeky like me, this augmentation of your brain is going to probably handle a lot of the technical details, as Mathematica might have back in the day. But the why requires maybe in a way you understand it even better than before. So this is me kind of riffing off of that question. What does it look like when we're using these tools most productively? In my experiments, and obviously in my sort of personal work, this is what it looks like. You are still fundamentally in the weeds of the problem. Better to think of AI as an expansion of your own cognitive capabilities than an army of robotic minions that are carrying out your every wish.
So essentially, we should take a lot of the mundane tasks that are repetitive, put it through AI, and then leave us as the creative function and knowing why the system works the way that it does.
Well, I mean, I'll push back a little bit, which is I think there are a number of tasks which are fundamentally automatable.
Sure.
I mean, probably there is a genuine hard human discussion. I grew up in the Salinas Valley of California. So this is where John Steinbeck is from, all of his Nobel-winning novels, In Dubious Battle and The Grapes of Wrath. And so I watched armies of human beings go out into those fields every day, growing up and still today, bent over in fields, picking lettuce. 25% of the produce of the entire United States and a meaningful chunk of the world comes out of these farms in California, grown by people California, or at least America, doesn't seem to want anymore. There's a reasonable point that human beings shouldn't be forced to do that. And wouldn't it be great if we had a fully automated farms that could do this? Is if we could find something for all those people to do to feed their families. So there are tasks which are reasonable to automate. But to note, what I'm really saying is, in the kind of tasks that interest me, there is very little that I would fully automate. Instead, a better metaphor, particularly for this crowd, is working with AI feels a lot like working with my graduate students. My grad students are brilliant. They know everything, more than I do, about the problem that they're studying, because for me, at best, it's 1 hour a week. For them, it's their life for years on end. So why am I there? In a world where they could look up answers on their phone, They could go to the library, but turns out at Berkeley we have a pretty good one. They could search the internet. Like, they're brilliant. They never needed me to give them answers about brains or about machine learning or psychology or any of it. Why am I there? Because my students know everything and understand nothing. And the point of spending those years with me or any mentor is to learn the understanding of the problem. We're scientists. Our job is when there aren't answers anymore. If there are answers, then it's an engineering problem. If there aren't, it's a scientific problem. Not denigrating engineers at all, and this is something people very much don't understand about medicine.
There goes my heart. You just crushed it right now. I'm an engineer.
Engineers are amazing. And figuring out how to apply what we know about the world to a novel problem is a superpower I do not possess. I've written a lot of lines of code in my life, but I'm not a delusional. I am not an engineer. But what I am genuinely good at is walking into a problem. In fact, really my entire job is no one can figure out what's going on here. This kid is dying. Nobody can figure it out. This company has fundamental flaws in its promotion process. No one can figure it out. This country did everything the World Bank says. Its PISA test scores, these standardized international test scores, go up every year. Nobody's hiring its citizens. It's doing every one of those cases. Everybody's doing what they're supposed to, and it's not working. My job, if I can be said to have a grown-up job, it is figuring out why it is we don't understand this problem. And so when I work with my graduate students, that's it. They're already geniuses, and they already know everything they need to know about brains and machines. I'm there to help them understand when uncertainty dominates and we don't know what to do next. In fact, I'm even thinking of putting a course together. Essentially, what is the course you would teach when everything we used to teach is no longer valid and useful? When it's free in your pocket from a chatbot. So that's our job. And when I work then, even going back to some of the original things I did with Bard, which was Google's original language model, was very much the same feeling. Except when I say it knows everything, I mean it knows everything. But boy, does it understand nothing. And if we really want to nerd out about this, I haven't released it except in my newsletter. I actually did a little case study, formally with analysis, of playing Dungeons and Dragons.
Tell us more.
I did one session with Claude as the DM and one session with Gemini as the DM. So we've got Anthropic and Google represented here. I had them all the way turned up at the time. I think Gemini 3 had just come out, so that was the sort of state of the art of the moment. But Claude's a better writer even at that time. And I gave it an immensely challenging task. This is just for the filthiest of nerds listening in. I had it take Dragon Heist, a sort of somewhat well-known adventure set in this one setting called Forgotten Realms. And I said, you know what, though? I want to play an Eberron. So for anyone who doesn't know what I'm talking about, imagine I took Game of Thrones, but a heist in Game of Thrones, but set it in Blade Runner, or a fantasy version of Blade Runner. So you have to remap all the characters. You have to change all of the mood to capture the punky but also swashbuckling elements of Eberron. You have to do all this stuff. 30 seconds later, the game starts. All the characters are remapped. The setting's great. The writing's great. I also said, hey, you know what? We'll use basic D&D 5 rules, but the worst thing they ever did was take out psionics, which is my favorite thing ever. So I'm going to play a psionic character. You have to come up with rules for it. And you're going to track all of the statistics for the game. So what did it do that was superhuman? first off, if anyone's curious about my opinions, yes, 100% agentic models are intelligent. That intelligence both overlaps and exceeds some forms of intelligence of our own. But as we're about to discover, there are some other forms of intelligence it simply doesn't possess. And there's never a yes or no question to these sorts of things. So what does it do superhuman? I mean, that writing and that remapping is just amazing. If a human being had even done it, it would have taken them months of time. Literally 30 seconds later, I'm playing. And by the way, I gave it the text of Dragon Heist and nothing else. So as far as the rules of D&D and Eberron, it pulled all of that in by itself. We can talk about copyright laws later. So that was amazing. And there were a number of other things that it did was really amazing. Things that were imperfect. Boy, did it want to make decisions for me. Like, it wanted, no matter how strongly I prompted, it wanted to tell me how my whole day went, rather than, no, wait a minute, let me play out this scene. So it really wasn't D&D in a traditional sense. It was more like collaborative writing. But it was still fun. But here's where it really flew. And what I actually had was I had Gemini and Claude diagnose each other as though they were neuropsychiatric patients. Read these full transcripts of months of gameplay and tell me where the likely lesions are. In other words, where did this person who was the dungeon master likely have a stroke? And these strokes were all deeply prefrontal because they had to do with some other interesting areas, because what it really struggled with was theory of mind. So there is somewhat notoriously, even though, again, this is super nerd detail for anyone who's not a D&D fan, for whatever reason, there is a Rakshasa as a throwaway NPC character in Dragon Heist. And if you know anything about Eberron, they are big players in the world of Eberron. So it's just coincidental that that's there. And it brings it in. So Rakshasa are these sort of super powerful demonic creatures. If you could really see them, they kind of look like a tiger person. But they're always under illusions. And effectively, you just can't break them. So my character walks in to the scene where this NPC is. And my amazing D&D, it turned out it didn't matter if it was Gemini or Claude, said immediately a chill runs down your back because the human shopkeeper you are meeting is actually a Rakshasa, a demon in disguise. But how would I know that? I mean, literally, I typed this. Obviously, I'm experimenting,
how do you know?
so I'm giving the LLM a lot of leeway here. But it turned out again and again and again, these systems could not keep clear what it knew, what I knew, and what my character knew. Everything bled through. Because again, these are superhumanly intelligent in some ways, largely about statistical learning and model-free learning, but fundamentally lack some of the basic, effortful, model-based cognition that humans have, which would include things like that any human would have gotten right, which is, I know something you don't. Not just as a statistical parameter, but as a fundamental model of the world. And it would apologize. It would say, I wouldn't make the mistake again. And then 3 scenes later, again, information bleed. And it was really interesting playing this. And so the diagnosis was this patient has had some sort of stroke in their medial prefrontal area, and maybe their caudate nucleus. We could run through all the things that they cross-diagnosed each other with, but they turned out they were very overlapping patterns. They look like a sort of, if you ever remember from anyone who took a Psych 101 class, what was it, Phineas Gage, the guy who got the spike through his head right here in the
Yes.
Bay Area back in the day, and he just suddenly becomes a different person. It kind of looks a little bit like this, that astonishing brilliance and facility with language is masking deep and fundamental cognitive limitations. They're both true. And the one, the limitation does not make the strengths less valuable, but it means you have a fundamentally different interaction. I've had employees that have varying challenges with autism, for example. And there are things that they could do that no one else on my team could do. And there were things where if I asked them to do it, it would be a pointless setup for failure. And understanding those differences, let me be clear, AIs are not autistic. I'm only using a really weak metaphor here. But understanding these differences is really revelatory about the nature of our interaction with these models.
All right, so you have this really interesting distinction you're just raising between knowing and understanding. One is much more tangible and concrete. One is more kind of nebulous and harder to pin down. This reminds me of a distinction that really struck me when I was reading your book, which is the difference between a goal, which is very tangible, like I want to win at this game or I want to get a high-paying job or have my business grow, and a purpose, which is these things that we should aim for to robot-proof our life. So I want to ask you to amplify that, but my technical question is, why do you think a purpose is beyond the purview of AI, at least for now? Like, why couldn't I just code in a purpose in Claude's constitution?
Yeah. So this whole concept of a purpose is interesting enough that you, looking at my background here, may see a poster with an elephant and a umbrella. That's my next planned book, titled Small Sacrifices, and the subtitle is The Science, Economics, and Story of Purpose. It is such a fascinating psychological construct that has such profound implications on people's lives that it just seems like, let's not treat it as a squishy idea left only to the poets. Let's understand in a measurable way what this means, even if measurement doesn't fully explain it. And one of the interesting and fascinating, I'm going to call it a purpose paradox, is if we define a purpose purely to operationalize it as having something in your life that's bigger than you, would take more than a lifetime to complete, I'm going to add in from my own research something you're willing to make a sacrifice for. So in other words, if it would never benefit you at all, and yet this thing is so important to you, you personally would take a sacrifice for this bigger thing to be true. A lot of the research also says it should be a good thing. I'm trying to, again, be a little hard numbers about it. I'm not seeing that that's the case in the research that I look at. It's just this thing, bigger than you, you're willing to make a sacrifice for. So your career is not really a purpose because obviously you directly benefit from it. It's something that plays out over the course of your life. For some people, a purpose could be spiritual. It doesn't happen to be for my personal sense of purpose, and nor does it have to be in the research literature. The classic line here is the world gets better when old men plant trees. They're never going to rest under its shade. And the interesting paradox is, even though they did this thing that gained them personally nothing, and yes, maybe some generations later, the kids of that village will have a tree to rest under. The interesting and almost paradoxical finding is that these people have better lives. They live longer, they have lower all-cause mortality, lower insulin sensitivity, lower central body mass, they have bigger friendship networks, they go further in their academics, they have higher lifetime wealth accumulation and higher average incomes. So think about anything you'd want to be true about you when you're 65. People that score significantly higher in purpose, all of these things improve. And there's a great paper in a very related concept of life meaningfulness from Andrew Steptoe and colleagues in PNAS. And then another paper that they wrote on life skills and life outcomes. which includes some of the other things I write about in the book. So you look at these things, and the more purpose goes up, the better people's lives. But wait a minute. The whole point of purpose is it's not about you. So why is your life better if you're taking actions? And I'm going to say from my own research, actions that for you in the moment are a sacrifice. Maybe we can call them altruistic or not, but I'm not going to get involved in that particular debate. Why does it make your life better? I think there's a lot of really hopeful things to be said about this, but let me be a nerd for a moment and say from an economic theory perspective, one of the possibilities here is it helps with alignment. It turns out when you see someone do something for reasons other than pure self-interest, it makes it much easier to, economically align with that person.
So
Whereas,
I have to ask here. So you went in the economics direction, and that kind of surprised me. I thought you were going to go to evolutionary biology, because I thought that's running through my mind as almost like a Dawkins selfish gene, that my individual survival is immaterial. I am part of this larger, you could say the species, but the selfish gene says, no, the species doesn't matter. Your gene is trying to survive. So when you say the old man is planting the trees, creating the shade, I would say, yeah, he's doing what helps propagate his genes, his species. And it makes sense to me intuitively that evolution would say, whenever you help your whenever you help your descendants, the future of you should experience joy. To me, this is an alignment of evolution, that when I do things that benefit the future, I should feel good. Do you think there's more to it?
It absolutely could be. I would say that a theoretical economic model of this is not, in a sense, incommensurate with a sort of evolutionary perspective, presuming we're describing a generalized sort of incentive process in one that's playing out over evolutionary time on the other. I just think that what's interesting is the degree that it plays out at the individual level when it needn't. When a lot of experimental work would suggest that it can't. So many models looking at altruism in theoretical sort of Bayesian-y kind of models just don't find it as a evolutionarily sustainable thing. Clearly it happens. So clearly, therefore, we don't understand it. Why is it's been so hard to really capture? One could argue that it doesn't really take in the time scope involved, whether it's evolutionary time scopes or, again, life time scopes, which is to say that we're engaged in many different interactions with other people in the world, with both strangers and close relations and kin, as the terminology of art in this kind of space. And these become really complicated and not just iterated over time in the way we might in a game theoretic model, but iterated in the real world. It seems to provide these benefits. Those two arguments, again, don't explain each other away. In fact, if anything, they might reinforce each other over time. It's just, to me, it's really helpful. We'll add on to this some great work from a couple of others recently. This is just a paper, maybe in PNAS, from only a few weeks ago. And I really loved it because it's wonderfulness and nerdy stuff all at once, because, of course, nerdy stuff is wonderfulness. But the argument of the authors was that if you look at the evolution of altruism, yes, it doesn't work in these models. Now we're getting back to, do averages exist? If, for example, you treat these big models as like a mean field theorem, like the lifetime average run of the model represents the full dynamics of the model in the short term. And what they said is, no, it turns out if you look at species, or I think they also imply this, cultural evolution, that it's highly non-ergodic, that the local behavior of populations is not captured in the global behavior of the entire system. So if you only looked at the averages, altruism can't develop, purpose has no purpose. But if you look at local, yes, defectors come in and undermine all of these collaborators. They undermine the altruists and the purpose-driven people. But over the long history, enough local populations where everyone by chance is altruistic or purpose-driven or something, that they then collaboratively outperform, and you get a positive sum local system, which then gets large enough that it can outperform the competitors. And then they say this, obviously, this is a sort of like a one theoretical component model, just this non-ergodicity component, but this can explain why it is that phenomena like this exist in the world. Because we are messy and unique. And that messiness, usually the positive versions of that usually die out. But every so often, enough of it happens in the same place at the same time that it propagates forward and then outcompetes. And I think a really interesting lesson, which I go to more, I will in my next book than in this one, is these kinds of sort of mathematical models of understanding our interpersonal interactions. A really cool one I'm working on right now for a theory paper, which then I will subsequently write up for some sort of an op-ed, is maybe one of the reasons humans are interestingly smart collectively compared to AIs is AIs are themselves an average of collective intelligence, whereas we are a collective of a whole bunch of weird, long tail, sort of non-ergodic trajectories in information space. A horrible way to describe a human being, but we are these things. And by not seeing everything and having our own highly idiosyncratic understandings of the world, we as individuals are not as intelligent in some ways as the bleeding edge of agentic models, but we as collections are more intelligent when it comes to creativity and innovation. And then the two together create really nice complementarities. So that, again, is my incredibly long-winded way to answer what should be a straightforward question about purpose. But I think genuinely it really boils down to what excited me about it was purpose appears to be a construct. I don't mean psychologically, an individual purpose is a construct. There isn't one thing you were meant to do in your life. This is something people build. Again, for some, they build a deeply spiritual purpose. For others, like me, you ruin your life and then you stumble across something to try and start it over again. And it's very grounded and human, but it's still impossible to achieve within a single lifetime. Are you willing to make a sacrifice for that thing? And I think the amazing and helpful statement is the people that build, not find, that purpose that motivates them to make these sacrifices, these terrifying sacrifices that feel like it's all a step off of a cliff with some weirdo like me promising you it will all work out, is that you do, with like strong statistical significance, live longer, have more friends, and even earn more money. And I think it's really, it is as wondrous and heartwarming a finding of science as any I can think of.
So one is, if we're looking at global AI and collective human good, where do you think countries and even individual corporations need regulation? I know sometimes this is the darker side of AI because we have to put up guardrails.
So I actually have it started as a whole chapter, and then along with literally the majority of my book, my publisher handed me a machete and said, this is never seeing the light of day until you cut 100,000 words out of it. So yes, my book was originally 1.5 times longer, or 2.5, depending on how you measure it. So, and some of that came out, but I wrote a Financial Times op-ed about this also. And in fact, I think it came out in like 2019 or 2018. So this is something I've thought about for a long time. I don't have to assume that AI is flawed. To understand that AI being built, large foundation models and the infrastructure to support them is controlled by a tiny number of countries and companies. And I don't have to think that Sam Altman is a bad guy to think that what is in his self-interest is not in mine. Not all of the time. And these machines are making incredibly intrusive decisions into our lives, sometimes with our knowing by our interactions with them, but also because of systems I have built in my career. They are deciding diagnostics. You go for a second opinion with a doctor. If they're using the same model, are you actually getting a second opinion? They are deciding who gets jobs, who gets university admissions, who gets extra attention from the police or Border Patrol. Again, you don't have to assume that the models are flawed or that the people are villains to appreciate that what is in my self-interest may not always be in the interest or in the cost functions instantiated in these models. And that is a serious problem. I mean, a deep and fundamental flaw. So, really for me are two responses. One is what to do about that almost legal question, if you will. And then the other is what actually is ethical AI and how do you really solve problems in the real world? So I'll start with the initial one. I wrote about what I call fiduciary AI. I simply do not think that you can have any modern concept of civil rights in this world. In a world where people do not have AI that acts explicitly in their self-interest. It would be like having a lawyer that worked for the government or having a doctor that worked for the drug company. Again, I don't have to assume they're bad people to think there will be times when their self-interest and mine conflict and I can't trust them anymore, which is why we have laws that require lawyers and doctors to act as fiduciaries or specialized financial advisors to act as fiduciaries. They're not perfect, and most of those are financial relationships. We don't have to expect this out of goodness of people's hearts. We need that in AI. We need AI tutors whose legal responsibility is to act in the best interest of the students, which would include not simply giving them the answer, for example. I need to bring an AI to court to counter the prosecutor's use of AI or possibly the judges. I should have systems that actively recommend me for jobs. So I write a lot and believe a lot in something which exists but doesn't have nearly as much traction as it should, which is data trusts, which are independent institutions that could collectivize people's data and represent their rights. Because even if you are incredibly technologically sophisticated, you simply cannot get around as an individual these issues. So I do believe that there's a role in governments for regulation, though not in legislators. They should create institutions, and 80-year-olds should have nothing to do with things they do not understand. Create nice, healthy institutions that simultaneously love and are deeply skeptical of things like artificial intelligence. They can't simply be skeptical because then industry will start to try and get around them. But we need that. We need companies. The original financial audits that corporations do as standard, all of that was originally voluntary because it was the only way to get people you didn't know to invest in your company. My understanding is that Vanderbilt came up with that to get people to invest in his railroads. So we need data and algorithm audits. We say our system does X, and it does. We have that weekly with existing benchmarks. But as I just said, I guess about the experiment I haven't had a chance to describe yet, benchmarks turn out do not predict hybrid intelligence very well. When our cyborgs were using small llama models, small open source models, they did almost as well as when they were using state-of-the-art foundation models. The benchmarks didn't turn out to predict much, and I virtually guarantee you they do not predict much about how AI actually affects the humans that use them. Those benchmarks need to exist. That's a project my nonprofit, the Human Trust, is actively working on now. There's a handful of some other groups that are just starting to do the same, but there absolutely is no standard benchmark on hybrid intelligence or on how AI actually affects human beings directly. But we also need data trust. Now, having said all of that, none of it has to do with AI for good or being ethical with AI. And a lot of our vision of that, as enacted in a lot of research and nonprofits working in this space, comes down to having boards and checklists and guidelines. And I hate to break it to you, none of that, all of that is secondary at best. There is no wise old man with a long white beard that's going to give you the right answers. I don't care how much time he's thought about the trolley problem. Someone's going to have to kill somebody with a trolley one way or another, and it turns out they're not going to help you. So, in my personal experience, ethical AI is essentially problem solving. It is different, though, than the kind of problem solving that many computer scientists are trained to do, or other kinds, which is, hey, we're going to get over a 0.25 percentage point increased accuracy on recognizing dog breeds on ImageNet, and you're going to spend the next 7 years learning how to tune metaparameters to make that happen. Instead, it's going to be when you then get hired by Amazon to build a deep neural network to decide who gets hired, and they say we're going to use our historical hiring data as our training set, and our ground truth will be whether they got a promotion in their first year. Owning the whole problem is, but I'm sorry, boss, who has the power to fire me, is that an actual causal relationship between Amazon's hiring history in the 90s and someone actually being causally good at their job? And if it's not, how are we going to adjust for that? And unfortunately, I'm describing a real case where, again, a perfectly decent company built such a model. It absolutely 100% would not hire women, at which point they did everything the ethical AI world said they should do, because they're not bad people. They're just humans. And they took out all the gender markers and all the women's colleges and every indicator that a human HR professional could see whether this is a man or a woman. And their deep neural network did something truly superhuman. It took the remaining data, figured out who was a woman, and wouldn't hire them. Now, of course, Amazon never put this into production. It didn't actually kick women out of the workforce as a result of this. But the problem to me wasn't that they didn't follow the appropriate ethical guidelines, because they did. The problem is they didn't own the whole problem. The idea here, the why, is we want to improve the speed and fairness of Amazon's hiring, that the people we're hiring truly are the best employees. And rather than anyone on the team raising their hand and saying, I think we have specified this problem incorrectly, our cost function will not actually solve that. Versions of this are going on in every major foundation model today, by the way. They kept their hands down and they did what they were trained to do, which was solve the engineering problem. And they did it amazingly well, and it made the world worse. They weren't villains. The tech industry isn't filled with villains. There are a handful. You can probably guess who I might think that they are. One of them is like genuinely a Bond villain, but whatever, that's their life choices. So I'm not saying there are no villains in this world. I'm just saying the vast majority of these choices are being made by everyday humans who truly believed that they were going to do the right thing when the world needed them to, and never even realized that the choices that they made other people's lives worse. So these are my two things. We need fiduciary AI on the legal front, and we need a curriculum of solving problems in the real world that spans the sciences and engineering and every other domain of scholarship, because it is not there right now in any field. I was on a working group with the noted economist David Otter, and I said as much. My students are some of the smartest, most thoughtful people I know. I have taken neuroscience ethics courses, and they basically amount to don't be a Nazi, which I used to think didn't need to be reminded of, but maybe I was wrong about that in this current version of America. But it not helpful. That is not a statement that actually causes people to truly behave differently in the real world. Because the time the world needs you to be the best version of yourself, if you haven't been practicing that version for years when it is easy, when the world gets hard and your job's on the line, or $1 trillion is on the line, I guarantee you will not be who you thought you were. And that has nothing to do with checklists or guidelines or advisory boards.
Exactly. Now, one last question. I know this is going to have to be the shortest answer that you've had today. What is one thing that you want people to take away from AI and tech, or even your book?
One thing for people to take away is the core story in my book is in the subtitle. If you want better AI, build better people. It is things like curiosity, intellectual humility, fluid intelligence, perspective taking, understanding what's going on inside other people's heads. These are the things my research shows predicts hybrid intelligence and successful interactions with modern AI. These fundamentally, deeply human things. I'd throw in some others that don't have enough time in experiments that I run to come through, but things like resilience. And I write about them in the book. These are the fundamental drivers of human value add in the world. The other fancy things that I happen to know, a bunch of neuroscience facts that we know how to do some fancy math, those are just tools in our tool belt. It's the artist that matters. AI may be the most powerful tool ever developed. It's still just a tool in our tool belt. But our education system doesn't just focus on the tool belt. It thinks we're just tools.
Maybe becoming robot-proof is not about beating the machine. Maybe it's about becoming more fully human, more reflective, more willing to ask why, and more capable of using powerful tools without surrendering our understanding to them. If you've enjoyed this episode of Breaking Math, follow us wherever you listen. Share it with someone thinking seriously about AI and technology in the future of work, and let us know what skill, habit, or human quality you think matters the most in an AI-shaped world. So until next time, keep questioning the systems, stay curious, and keep building better people.